Data and the availability of data is the value part of any business proposition that you're working with. The resources at the underlying ways to deliver that data to you are important, but the data itself is going to be super important to make sure that it's safe, secure, reliable, and always available. Azure storage accounts are going to give us that capability, as well as teach us several base components that will allow us to understand how Azure as a whole performs a number of its magical duties. With that, my name is Bob Tickelman. I'm excited to be your guide for this module on Azure Storage. Azure Storage is a foundational tool for the storage of information. It's going to provide a wide variety of configurations that will meet almost any business requirement that you have. Where it's going to fall into the categories of unstructured data and lightly structured data. Highly structured data like SQL is not going to be available. It's done in specific tools, but you'll see in the storage account, we have the capability to have those two types of storage of unstructured data, that traditional hard drive that has XLS, doc files, EXCs, INIs, that variety of unstructured data, as well as having some lightly structured data, very similar to a table structure you're working with. So we're going to take a look at a deep dive in storage, and by learning these skills and understanding the deeper components of how they do their work, it will reveal on a whole how Azure does a lot of what it does. So with this, we're going to take a look at storage accounts, the kinds of accounts that are available, and use case scenarios of how to deploy and get the best business value from that. A storage account is a regionally based unit of storage and replication. I've been using that line since I've been teaching Azure, and it sounds kind of straightforward to me, and I've said it so many times it just makes sense, but I want to stress this again. An Azure storage account by itself doesn't store anything. It is a regionally based. So we're going to go and take a look at what that means. So if you have to store stuff in two different locations, maybe in North America and one in Europe, you would need two different storage accounts, one per region. Now, if you have two locations in North America, one per region, so you'd have to have one for each region. So a storage account is a regionally based unit of replication. We're going to dive deeper into this and take a look at the different ways in which Microsoft makes the storage information highly available, ranging from anywhere from 11 nines to 16 nines of high availability. So that's 99.99999999999 times, which is far beyond what most people look at of the 5 nines that we all strive for in our on-premise world. So a storage account, regionally based unit of replication. If you needed two different types of replication, and you'll see that there's multiple types, up to 6, you're going to have two different storage accounts for that. Okay, so let's go off and do some whiteboarding, and we're going to come back and take a look at how that gets implemented, because I want to understand the base components before we go in and take a look at the types of storage that can appear in a storage account. So starting off with that comment about a storage account is a regionally based. We've seen this map in other recordings where these are the current 67 regions that are available in public Azure. So if I wanted to store something here in this location, I would need a storage account. If I needed my application having it in North America in that location, I would have a storage account for it. Now, we've also shown you in other recordings what a region looks like. So this is US East, which is our biggest region. It's our favorite. It gets everything first. US East, this picture in the upper right-hand corner is what it looked like in 2014. Each one of these data centers has its own standalone redundant power, network connections, air conditioning, cooling, all of that stuff. And you can actually see different designs, what we call our Gen 1, our Gen 2, and you'll see that in 2017, we added a significant amount of resources. So that picture in the upper right is that piece right there. We more than doubled the capacity with our advancements in 2017, and it's changed even since then with these massive data centers that you're working with. And the reason I show that is because I want to talk about this thing called an availability zone. And then we're going to go in and take a look at what happens inside of the data center itself. So an availability zone is a way for Microsoft to obfuscate the data center structure. You don't get to pick a data center. What Microsoft does is we then balance the load across the region so that we don't fill up all the resources in one data center. When it's full, we go to another data center, fill it all up, because it would then provide single points of failure. What we do by making availability zones available to you, I have Blue User who has availability zone 1, 2, and 3. They have 3 zones, and what Microsoft will do is we will determine which data centers make up zone 1, 2, and 3. So for Blue User, this one might be 1, this one might be 1, this one might be 1, this might be 1, this might be 1. Zone 2 is here, zone 2 is here. We got a couple of 2s up here. Got a 2 here and a 2 there. Zone 3 might be here, 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 3, 3, and 3. So all of the data centers that make up that region will then be identified for Blue User, whether it be a zone 1, zone 2, or zone 3. So you might get one of your applications in zone 3 put there and another one put into a different zone 3. But it's now spreading this load across multiple data centers, limiting the potential chance of a single point of failure. Doing the same thing for Green User. They have a zone 1, zone 2, and 3. Their zone 1 might be here, here, here. It might be zone 1. Their zone 2. And their zone 3. Won't go into the same one. Zone 3, zone 3. So we'll spread them around that vary from user to user. It's not the same thing for everybody. So understand that zonal concept. Now I'm going into deep dive on this because this technology is going to be the same thing when we get into a whole nother set of recordings later on when we take a look at a thing called PaaS, or Platform as a Service, and things like App Service Plans. A lot of those ideas are going to be replicated on this concept of Azure storage. So I'm doing a deep dive here, and when I do those later recordings, I'm going to refer back that someone comes and watches this specific session, because I'm not going to do this in all of them. I'm not going to repeat that, but this is going to be a deeper dive. Learn it once and you'll be able to use it many times over. We saw that within a region, there is one or more data centers. That's great. So we're going to take a look at what happens inside of a single data center. Inside of the data center, we have things that are called scale units. Now, this is a concept that's probably well beyond what most people need to know, but I feel, especially as administrators, the more you understand this, the better you're going to be able to guess other topics. What a scale unit does is define a configuration that is deployed to a node set or a group of computers. So we may have a scale unit that is specifically designed for storage. We might have a node set that is going to be configured for compute. And so everything in that scale unit will have a single configuration, and we might have multiple scale units of a similar type. Each scale unit then has a term called a fault domain that indicates a single point of failure within the set of scale units. So it's hierarchical. A scale unit has a set of fault domains that make up similarly configured devices, each having a single point of failure. Now that single point of failure typically becomes a thing called a TOR, or the top of rack switch, that are 2 of them that are redundantly connected back into the backbone of Azure's communication. We have the PDUs, or the power distribution units, that again are redundantly connected to all of the nodes that are on that scale unit. Inside of them we have nodes. We got node 1, node 2, node 3, node 4, and so on. So a scale unit has these, and they have, I've put Windows in there. We actually have our own operating system, I'll call it Azure, that is deployed to these nodes. Now let's take a look at how this comes into play. A storage account is a regionally based unit of replication. I have a file. I've got bob.doc. That file is going to connect to a thing called a resource provider. Now, if you saw the recordings, you would have seen this diagram. I have my bob.doc that if I'm looking at that file, it is accessed, and we saw in other recordings, there's different ways through the graphical interface, through CLIs, bash, command line tools. you're going to connect to, in this case, the storage resource provider. And we saw again in a networking component that we talked about creating a service endpoint. So storage is an Azure service. Now, I've talked about in other modules as well, some golden rules that appear at Microsoft. In general, child objects inherit things from the parent. Go see those modules. Permissions are cumulative with the exception of deny. Again, talked about in security modules. Here, all data in Azure is stored a minimum of 3 times. I don't care what it is, a minimum of 3 times. So what will happen is my bob.doc, however I've decided to store it, is going to hit the storage resource provider. And here's the eye winking moment. The thing, it is synchronously connected to all 3 copies. So someplace in Azure, there's going to be 3 full copies of that bob.doc file. This is not RAID. It's not redundant array of independent or inexpensive disks where we're putting portions of it across multiple disks so that if one fails, we have 3 distinct copies that are synchronously connected. And if I make a change, it is synchronously connected to those 3 copies. Now we're going to refer to that term called LRS, or locally redundant storage. You'll see this when we get back to the PowerPoint slides. But LRS synchronously connects to those 3 copies, and we're going to then see how that plays out in the data centers itself. So I've got my bob.doc connects to the resource providers, and it's now going to write 3 copies of that bob.doc file someplace into an LRS, locally redundant storage, into a single data center inside of the region. So as I'm drawing this, I'm hopefully some of you are thinking like, Bob, what are you doing? I've now put those 3 copies into the same fault domain. This is not a good thing because if the TORs go down, I lose the entire scale unit, meaning I lose access to my 3 copies. So that's not what happens. I want some of you, while I clean up here, I want you to think of what you think is going to fix this problem. What it does, instead of writing 3 copies into the same 3 fault domain inside of the same data center, it's going to spread it across 3 fault domains. And this is where those 11 nines of high availability starts to come. I've now got bob.doc across 3 different fault domains so that if I do end up losing a single fault domain, I still have multiple copies of that information. Now be careful, this is not a form of backup. It is high availability, because if I make a corrupting change to the bob.doc document, remember it's going to synchronously make that corrupting change against all 3. This is not a replacement for backing up. It does not guarantee a point in time recovery back to your data. Well, maybe I'm going to give you some examples of that. But by itself, a storage account is just for high availability across the 3 fault domains you're working with. So you're going, well, that's really good, Bob. But what happens if I lose an entire data center? Which could happen. It happens infrequently. And I know of one back in 2018, one of our data centers in South Central US, if you're familiar with that geographic area, sometimes called Tornado Alley, a single data center was hit with over 19 strikes of lightning and took an entire data center off, but the rest of the region was up and running. So what we now do, we give you an option instead of LRS, we give you an option for ZRS, Zone Redundant Storage. I still have my bob.doc file, this time it's a green one. It's still within the same region, but now it's going to go to a zone. And I still have 3 copies, but now those 3 copies are across 3 zones within the region. And this way I could potentially lose an entire data center and still have access to my resources in that region. Pros and cons. You're going, Bob, why don't I use ZRS everywhere? Well, the problem with ZRS in some cases is there's potentially a sub 2 millisecond latency between the communications of all the data centers within that region. You don't get that level of latency potentially in an LRS solution because they are, very close together, connected by fiber channels. So Microsoft guarantees sub 2 millisecond latency for those copies to be synchronized across the region. Well, what happens if I lose the entire region? Well, guess what we have? These people have thought of everything. We've talked about LRS, which then puts your 3 copies into 3 different fault domains within a single data center. We've taken a look at ZRS, that's going to put your 3 copies across 3 different zones, but within the same region. There is an option to have GRS and GZRS, globally redundant storage. So now what it's going to do in the case of LRS, I should maybe put that letter back in. LRS not only copies 3 copies redundantly, synchronously across the same data center, it now takes and to a region pair. Going back to that map, remember Microsoft pairs our region. US East is paired with US West. US East 2 is paired with US Central. So if you set up GZRS or GRS for globally redundant storage, it now takes 3 copies and asynchronously replicates those copies 3 in another region that is paired. You don't get to pick this. It's the region pair picked by Microsoft. Now, this async, Microsoft talks about a delta potential difference of up to 15 minutes. Again, it's not instantaneous. Know that there's a point in time that it will replicate that stuff across to that other paired region. Now, I'm not going to get into all the details. This also provides high availability that if the entire region goes down, what Microsoft will do is, say if you had a www page that referenced the IP address, if you go take a look at the networking modules where we took a look at things like application gateways, if you had an application gateway accessing the data here, what Microsoft will do is we will then reroute that to the globally redundant data that's running that application in the other region, knowing that there may be information that might be out of sync. So what we often recommend for this type of replication on a global basis is that you make it data that changes infrequently. I wouldn't use it for database replication. There's other and better methods to do that, but for read-only files or information that changes infrequently, and you could live with potentially losing some of that in the case of a significant outage and the automatic failover features. So we're going to go back and take a look at some of these, but know that there's multiple types of replications that a storage account can have. And if you wanted one or more of these, you would have to have one or more storage accounts because a storage account is a regionally based unit of replication. Now, we don't have time for it in the entirety of this class, but there's also going to be a few features that I'll show you in the live demo that you now can actually replicate some or all of a storage account to any other region of your choosing. It's not going to be, the level of a storage account. It's going to be up to you to manually say, oh, this container in this storage account, I want that information maybe over in Europe. You can set up manual replication of that information that will be, done on a regular interval, but it's not part of the normal storage account infrastructure. So hopefully that has helped you with understanding the components and how they work from a replication perspective. So with inside of Azure, the storage account has different types of data that it can work with. We have containers and files. These are what we call unstructured data. Unstructured data, as I've described, that's your traditional hard drive that has EXEs, MP3s, DLLs, INIs. It's got your .docs. It's got this unstructured set of data in whatever format kind of randomly spread across it. Now, those containers store what are called blobs, or binary large objects. We're going to get into more of this in a few minutes, and you can see there their images, documents, videos, audio, all of that information. Now, blobs, or binary large objects, are a new format to be able to store this, and they can be massive in size. Some of you probably ran into a 4 gigabyte size limit in the old file share models that you were working with. Blobs are more of a new modern method to do this, and it uses an HTTP or an HTTPS method to actually access that information. That's an eye-winking moment for you if you're going to take the exam. If you get a question saying, you're looking to access information over an HTTP request, that information should be stored in containers or blobs. Files and file shares go back to that traditional file service management system that you're used to. And it has directories you're working with, and it uses a thing called SMB, or server message block. This is secured communication, and it's very fast from a protocol perspective, but know that there's a difference between the protocols themselves. Again, it has a wide variety of unstructured data that you're working with. Tables and queues become this lightly structured data. I'll show this in the live demo. We're not going to get too deep into it, but tables provide what are called name-value pairs. They can be used to store lightly structured data. If you're used to this, you might have heard terms like MongoDB, Gremlin, Cassandra, lightly structured data. And I'll use the example of it's like an Excel document. It's got rows and columns with name-value pairs. The name of first name, the column header, has these values. Last name, these attributes, so those name-value pairs. Queues fall into one of 4 queue types that we're working with, which become buffers to put data into that might then be a stopping point off to its next stage of its existence. So, I think of queues very much like the phone. If you have only so many operators that can answer the phone, but you have more people calling in, they may get put into a queue waiting to actually be processed. And so from a technical perspective, if you're an application developer, this is what we often call decoupling. We have the generation of information, and we need to decouple it from the back-end storage or use of that information. We put it in the queue so it doesn't get lost, and then the back-end can pull the information out of the queue. But all of those data types are potentially available to store in a storage account inside of a regionally based unit of replication. Inside the blobs, they actually have several different types of blobs and the storage accounts themselves. I'm going to say the vast majority of you are going to be working with standard V2 generations of storage. They provide the most wide range capability of the type of data that you can store inside of them and for use cases. And they're pretty good general use utility capabilities. If you need some high performance, what we often refer to as ultra disks, the speed, if you're familiar with terms called IOPS and throughput, you're looking possibly at like 50,000 IOPS performed by your standard disk, whether you're using standard HDDs or premium SSDs. When you get into a premium block, you're getting things into ultra disks that will get you into 160,000 IOPS. So significantly more throughput, but you're going to get less choices. I'll again show this in the live demonstration when I get to the portal. So these are going to be high performance requirements. We have all those capabilities available for you. They will also restrict the number and type of replications that are going to be available at the storage account. I've already talked about the region pairs, so here comes through, taking a look at the region that you're dealing with. I introduced the term of LRS, or locally redundant storage. If you need it copied over, you go to geo-redundant storage. If you need to make it highly available within inside of a region, you can have zone redundant, and we have geo zone redundant storage as well. So those become the different types, and we have a version that is going to make it read accessible, or RA. So when I get to the demonstration, you'll see that I could make it read accessible geo zone redundant that you're working with. So that if I have a geo redundant copy, maybe I've got the read-write copy in the primary zone, and that's where my changes are going to take place, but infrequently. But let's say I have an application that is, backlogged and it can't get access in a timely manner from the primary region. Potentially, you could write your application to get it from a read-accessible version in the region pair version you're dealing with. Here are the different copies. I've done all of this for you, so I'm going to go through this pretty quickly. The LRS provides 3 copies and provides it in a synchronous connection inside of a single region. ZRS provides 3 copies in a single region, but protects it, here again those words, synchronous. If you get into a multi-region, you have a primary region with GRS, and then you're going to have an async replication, that delta time of approximately 15 minutes or no more. to another region, and then you get into the read accessible geo-redundant. So it's very much like the geo-redundant, but what happens is you now have a read accessible version. So if you've got millions of users that are hitting your primary site and it's overrunning it, potentially you could actually have it fail over and potentially read that information from that other copy. So instead of waiting in a long lineup to get to that one copy, you're going, hey, there's another door I get over here, but that's up to your application developers to work with. And they don't have the read accessible geo-redundant storage that you're working with, so there's GZRS. So geographic zone redundant, and then we get RAGZRS. So those are the 6 different types of storage that you can work with throughout the Azure storage account, those different replications. How you access a storage account is based on a URI that might be familiar to you. Now, another eye-winking moment, you must remember this format. So what you have is, starting from the right, going to the left, you've got a core.windows.net that is the same for all types of storage in the storage account. Then you get the type of storage, whether it be a table, a queue, a blob, and then you get the storage account name. And it's because of this, it's maybe publicly accessible, your storage account names must be globally unique. I'll do an example of this in the live demo. I'm going to put the name of a very well-known company. It's going to say, hey, that company, that name's already been used. So it has to be globally unique. And we've also added a recently new feature that provides an appended value to the storage account name that makes it globally unique. So if you come up with a name, but you do want to have a common naming structure. Now, what you can do, we talked about DNS in a previous module, you can use your DNS records to take that really long name that may not make sense to anybody for the storage account name. You could then convert that into the name that you actually want to use, using my example of that company. I could take this really long name that doesn't make any sense to any of us, and I could then convert that into a simple name that I could then make available to my developers and my users to access that information. In a networking module, we talked about this thing called service endpoints, where you could then connect a service like Azure Storage to a virtual network and its subnets that you're working with. That sounds an awful lot like storage endpoints. It's not. A storage endpoint is going to talk about how do I make my endpoint available and some of the network configurations that I can put on it. Do I want to make it publicly accessible, or do I want to embed it only to specific subnets inside of my Azure configuration? What kind of routing do I want to work with? So this is different than if you've watched that module on networking where we took a look at service endpoints. These are just ways to secure the endpoint that people would use to connect to the storage account itself. So let's go off and do a live demonstration, show you some of these features in action. Okay, so what I want to do is walk you through the stages of actually setting up a storage account. I'm not going to create it because I've got one already done. And then I'm going to go through the configuration of a storage account. So the first step is, I don't know if I mentioned it during the presentation side, not all services are available in all regions. It's kind of a general statement around Azure. And I'm going to demonstrate that some of the replication types that we talked about in the presentation may not be available in all regions. So I want to do that demonstration, and then we'll take a quick pause, and then we're going to move over to a demonstration of the configuration of a storage account. So to create a storage account, a lot of this has been seen in the other recordings where you have to have a subscription and a resource group. Your storage account name has to be unique, and you'll see this when we come up in the creation of the storage account demo. But I'm going to come to US West 3, and I'm going to compare this to Canada East in just a second. We saw that there was characteristics of a standard versus premium account. I'm going to focus on the standard here, where you can see all the different types of replication that we talked about in the lecture. We saw that we have locally redundant, geo-redundant, zone-redundant, and geo-zone redundant. And this checkbox down at the bottom gives you the option to make the geo-zone and the geo-local redundant storage read accessible. So you can see that checkbox goes away for zone and local, but once I go to the geo options, it gives me the choice to make that geo redundant read accessible. Now I'm going to switch over to Canada Central, as I said. Or sorry, Canada East. And you're going to see that not all those replication types are available. You only get local redundant and geo redundant. The two zonal options of zone redundant and geo zone redundant are not available because not all services are available in all regions yet. It's coming to Eastern Canada, it's in Central Canada. So just make sure that you check those before you try and deploy a resource type into a region that resource type is available in that region. So what you've seen is a storage of durable data that you might need to have offered through a storage account. It's just one of the types. We have other types for lightly structured, things like Cosmos DB, Redis Cache, and we also have features like SQL that you can use in a variety of forms. But for raw data that you're looking at, whether it falls into that unstructured or lightly structured model in the traditional file shares or this modern method of blob storage, storage accounts are the fundamental unit that you want to use to configure to deploy storage. Now with that as your background, there's going to be a whole bunch of other configurations that we will cover, but in this one we just needed to have you understand the basics of storage. Thanks for joining us for this session. To continue your learning, watch other videos in the course or explore more on Microsoft Learn at aka.ms/learn.